we begin, we're going to talk about box plots in this particular video, and I just want to begin with a cautionary note. The cautionary note is this: the minimum and the maximum are not always what they seem. The minimum and the maximum, yes, I get the idea: minimum, lowest, maximum, highest, but it's not always that simple, or it is only that simple when there are not outliers. When there are outliers, that changes just a little bit. Show you what I mean. Here's a nice graph, a picture of box plots and everything going on. The minimum is normally the lowest score, but if there are outliers, it should be treated as the lowest score that's not an outlier. Okay, if you don't have an exact score there, just calculate the first quartile minus 1.5 times the interquartile range. As far as the maximum goes, if there are no outliers, then the highest score is the maximum. If there is an outlier, then simply calculate the third quartile plus 1.5 times the interquartile range. So that's how you find the minimums and the maximums. The lowest score is actually the minimum when the 1.5 times interquartile range does not create an outlier. Likewise, when there are no outliers on the maximum end, by adding the 1.5 times the interquartile range, then the maximum, the biggest score, is actually your maximum. Okay? So keep that in mind. Outliers are not part of the minimum or the maximum. As far as the interquartile range goes, that's the 50% of scores that are between the first and the third quartile, which are the 25th percentile and the 75th percentile. The median is the score in the middle. Now, when we make a box plot, take a look at what shape is in the middle. It's a box. So that's why we call this a box plot. And years ago, we used to call it box and whiskers because there was a box in the middle and they thought of these purple segments as whiskers coming off the end. Okay? When you make an interquartile, a box plot, what you're really going to focus on is this. You're going to always mark the minimum, which may or may not have an outlier to it. And you're going to mark the maximum. Okay? The mark should not have outliers one way or another. Whether or not the outliers affect the minimum or maximum, that is to be determined. Then you're going to mark the third quartile, and you're going to mark the first quartile. In either order, it doesn't matter. And you're going to mark the median. So around the first quartile, the median, and the third quartile, you're going to make a box. And then you're going to split the box, not in the middle, but you're going to split it wherever the median is. If the median is closer to quartile 1 or 3, that's where the split goes. And that, your interquartile range, IQR, is the distance between the first and the third quartile. All right, so let's take these ideas and start to use them. Now, consider again the data set. We already did this data set, okay? Now, the first quartile is 2, the median is 7, and the third quartile is 9. Those are the numbers that are going to make the box in the middle. The smallest value is 1, the largest value is 11.5. And remember, when we did this calculation, there was nothing that was an outlier in this problem, okay? So what would your box and whisker plot look like, or your box plot look like? Well, it would look like this. The first mark I make is the minimum. The minimum is 1. There's my smallest number right there. Then I look for my maximum, 11.5, and I make a mark there. Then I look and I remember the first quartile is 2, I make a mark. The median is 7, I make a dotted line going up and down. You could put it like a dot in the middle of that dotted line. That's fine. That's usually how people do it. And then I make a mark at 9 because that's the third quartile. Then I make a box. Whoop, went a little too far there. And always a dotted or broken line above the median. Here they're calling them whiskers. The 2 whiskers extend from the first quartile to the smallest or minimum value and the third quartile to the largest value. It is important to note that with a box plot, you always use a scaled number line. The whole idea behind a box plot is this. You want to be able to take a look at this thing and get an idea how spread out this data is. So if there's not a consistent scale that you're drawing this on, then you can distort how spread out this data is. So we want to make sure that we have a regular scale interval, all lengths being the same, 1 to 2 to 3 to 4 to 5, and so on. Okay? All right. So let us get to one more box plot problem. The following data are the heights of 40 students in a statistics class. 40 whole students. That's a lot of students. Construct a box plot with the following properties. Don't worry about using a calculator. Okay, we got minimum, we got maximum, and finding the quartiles. Now, they were really, really nice to you, and they found the values, so you don't have to. When I said there were 40 scores, man, would you want to find the 40 scores, line them all up in a row? Ugh, that's a lot of work. So instead, they did the work for you. Draw your box plot. Go ahead, and then I'll show you what it looks like. Stop and start time. Ta-da. There's my box plot. The minimum value is 59. Maximum value is 77. First quartile is 64.5. Notice how it's marked. Okay, 66 for your median value, and 70 for your third quartile. Notice that like this distance here is 1.5 from 64 to 66, and this distance of 4. So there is a sense of scale measurement with this box plot so that you can see how it's going. Notice the box drawn around the interquartile range here. Notice the broken line or dotted line above the median. Those are characteristic common to every single box plot that you will ever do. And then the whiskers going out to 59 and to 77. Okay? So, what are some of the conclusions that you can make based on this box plot? Well, each quarter has approximately 25% of the data. So from 59 to 64.5, there's about 25% of the data. That covers a pretty big spread there, especially when you compare it to the 25% of the data that's between 64.5 and 66. And if you go look up at the list of grades here, or the list of heights, if you look in the middle here, 64, 64, 64, 65, 65, 65, 65, and so on, there's so many grades, so many people with that height, it only covered a short number of heights that 25% of those people were crammed into. 25% from 66 to 70, and 25% from 70 to 77. The spreads of the 4 quarters are, this has a spread of 5.5. You just subtract to get it. The next one has a spread of 1.5. Just subtract. 4 and 7. So the second quarter has the smallest spread. It's very close, 1.5. Okay. The range is the maximum value minus the minimum value. If I subtract them, that's part C here, I get 18. Interquartile range is going to be the third quartile, which is 70, minus the first quartile, which is 64.5. That gives me an interquartile range, IQR, of 5.5. The interval from 59 to 65, from here to here, has more, 65 is somewhere in the middle here, more than 25% of the data, so it has more data in the interval 66 through 70, which has 25% of the data. So, in other words, each of these intervals, from 59 to 64.5, 64.5 to 66, 66 to 70, and 70 to 77, they all have about 25% of the score. And when you take, and you go past 64.5 to 65, well, you're getting past from 59, 25% of the scores. It has to be more than that, okay? And last, the part F, the middle 50%, the middle half of the data has a range of 5.5 inches. In other words, that's what the interquartile range studies, the middle half of the data, not the end halves or the end quarters, but the middle half. And that's third quartile, first quartile, right in there, okay? And that range is 5.5. It's 7 minus 64.5, 64.5. Okay? So that, folks, concludes our initial study of box plots, interquartile ranges, and quartiles and percentiles, and everything else. All right? We'll make sure we have a homework put up there for you to do as well. This concludes lesson number 5.